integration as the limit of a sum. You see the diagram, this diagram, we are making some strips. So this is y is equal to fx function. Because it is real valued function, we can always draw some graph of this. This is x-axis, this is y-axis. So we are drawing this graph. Y is equal to fx. Now along x-axis, you make these strips of with delta x. So this is delta x, or it is here we are making it with is h, not delta x. With is h. So first point is, suppose we are considering from this point A to this point B. Then we are dividing this interval. Interval length is b minus a because b is greater than a. We are dividing this to n sections, n sections of width h. Means what? N into h is b minus a because there are n sections. Width length is strip width is h. So n into h is b minus a. Now consider one strip here. This strip, so each strip is having width h and length, you see this green strip, you see. So this one, the left side, it is here, we are making it. So this strip, so this is the lower part. So this strip, it is one part. When it is a plus h is up to this length because we are measuring fx in y axis. So measuring fx in y axis, so measuring fx, so this is fa, this point, this is f of a plus h, and this portion is, this is f of a plus twice h. And in this figure, this one is smaller, this part is smaller, this f of a plus h is smaller than this one. So you can consider this f of a plus h into this. So this gives you the area of this rectangle. So you are getting area of this rectangle. Therefore, integration, when you say integration fx dx, means what? You are adding this f of a plus h into this h. You multiply this, means you are adding this area starting from this point A to last point is this one. So from this strip to this is the final strip. So this is the final strip. So getting it? Means what? This is the limiting sum of fx into dx, and this gives you the area. So yeah, h is, so this when h is greater, then this value is greater. When h is going smaller, then this value unestimated, this value is unestimated because we are taking the rectangle only. So sometimes it is not estimated or sometimes it is overestimated. So this also, this is error. This is error. We are not computing this value. It may be sum, it may be subtraction. So this is error. So this error becomes less. This error becomes less and we are having this. So you see now what we are writing here. See now. So fx is a continuous real valued function defined on a closed interval a b. The interval is divided into n equal parts of width h by inserting n minus 1 points a plus h. So these are the points we are inserting at constant level, constant interval, equal interval is. So these are the points in between A and B. So there are n minus 1 points, so we get n divisions. So n and this n into h, this becomes U minus m. Now you consider this sum h into f a. So this h into f a is the area of this one, h into f of a plus h area of the second rectangle, h into f of a plus h etc. So you go on, and you will stop at, you are starting at a, so you are to stop at a plus n minus 1 is, or if you start at a plus h, you have to stop at a plus n h etc. And this h, this is the sum. So in the above figure, area of one strip is approximately area of the rectangle, area of the rectangle. So this above figure is bounded by x equal to a and x equal to b, x axis and the curve. So when n is very large, then h is very small. We are taking the limiting value. We are taking the limiting value. So limit s n tends to this and infinity. This is the indefinite integral. Sorry, this is the definite integral. Limit is from a to b, and this is the area bounded by the x equal to a, x equal to b, y is equal to f x. So our definite integral, it is the limit of a sum. So our heading is this one. So integration as the limit of a sum. So this integration, this definite integration is a sum actually. Sum actually, it is limit of sum. So if we when this is given, we can find this as some sum. You add this area of the rectangles and then take the limiting value and you will get the integration. So value will be same. You this add this, you take the limit of this value, or you use this formula with this value, so we will have the same value. So first one, you see how it is doing. So our fx, so h is always common here, h is the width of the interval, and this is, see how we are writing this one. So our function is x. So x is, we are starting from 0. So x is 0 here, because fx equal to x. So x is 0. Then next is 0 plus h, next is 0 plus h plus h, etc. etc. Ultimately, last point is n minus 1 into h, and last one is nh, nh is equal to 1. So this is just computation. So this is h is here, h you taking out, this h you take out, and here, so it is h square. So this is h square. Is 1 plus 2 plus n minus 1. Then take the limit, and we are applying this one h square. H square is what? It is h square is, h is, nh is equal to 1. So h is equal to 1 by n. So h square is equal to 1 by n square, and this limit is 1 by 2. You find it, you will get it. And if you apply the formula of integration, x square by 2. So this is, if you apply the formula, so it is x square by 2. Then from 0 to 1, 0 to 1. So 1 by, so this one is 1 by 2 minus 0 by 2. So answer is equal to half. Same value we are having. But this is the procedure for procedure using limit. Next you see this x square plus 1. See how it is doing. So we are separating this one. So x square means or actually first thing you have to write lower limit is 0, upper limit is 2. So f of 0. So f of 0, fx is equal to x square. So f of 0 is 0 square. 0 square is 0. Next one is 0 plus h, f of 0 plus h. So 0 plus h whole square and you are getting h square. And 1 is constant, there is no variation. Here x is varying, we are having varied x, but 1 is constant, so 1 is always remaining same. Then it is f of 0 plus twice h whole square, this is 0 plus n minus 1 h whole square, and ultimately we have this n minus 1 h whole square, this is plus 1. So how many ones are here? N ones, because n divisions are there, we are adding n values. So n into 1. So n into 1 is this is n into 1 is n. So h into n, and these are h square you take out. So after h square taking out, you have 1 square, 2 square, 3 square, etc., etc., after n minus 1 whole square. So this thing you are having, and you had some result. Actually, you had some result. You had some result. This sum of square of first n natural number. So this is given by the formula n into n plus 1 into twice n plus 1 divided by 6. So this is square of sum of square of first n natural number. So writing here it is, because our this is n minus 1, it stops at n minus 1. So in place of n you are writing n minus 1 and you add it and taking limit you know how to find these limits, and you are getting the result 14 by 3. And using formula, what you will have using formula, it is integration of x cube x square plus 1, this is equal dx is equal to x cube by 3 plus x, integration of 1 is x, and it is from 0 to 2, 0 to 2. So it is 2 cube 8, so it is 8 by 3 plus 2, 8 by 3 plus 2, and the other part is 0. So this 6, it is 14, 14 by 3. So using formula also you have the same value, but you have to find not using formula, but to finding the, you have to find the limit of this sum. So all are same procedure. So 2x square, it is 1 square plus 1 plus h whole square plus h. So limit is 1 here. Then it is 1 square plus 2h plus h square plus. So it is we are making some pattern here. So you add these things. So coefficient of constant term first you separate, then you find coefficient of h. So coefficient of h is, first it is 2, then it is 2 into 2, then it is 2 into 3, etc., etc. And square term also here. So you use the formula. So h twice h by this one and then you write NH is equal to here it will be NH is B minus A. So here NH is 3 minus 1, it is 2. You put it and you will have some limit. So this one is a limit. Then it is same procedure. It is from 2 to 6, etc. And number 6 is it is e to the power x. E to the power x. So e to the power x. So f of x plus h. F of x plus h you have to write e to the power. So f of this is e to the power x. So you have to write e to the power x plus h. F of x plus h, or it starts from 0 or whatever it is. So it is x plus h. In place of x is just you write 0. So this is product e to the power x into e to the power h. That is why you take common this e to the power x. E to the power x is 0 here because it is starting from 0, and we are getting is common, and this is a GP e to the power h, e to the power h whole square, e to the power h whole to the power n minus 1. This is a GP, geometric progression, you got in first semester. So this is geometric progression, and this sum is GP if A R etc etc, it is a GP. Then its sum is what? A into r to the power n minus 1 by r minus 1. So this is the sum. So here e to the power h is r, common factor. This is common factor. We are multiplying by e to the power h every term. So e to the power h whole to the power n minus 1 divided by e to the power h minus 1. And this limit you have got it, e to the power h minus 1 by h. This same, this is same. This is e to the power x. It is a is 0 here. Here a is minus 1. Then 2 to the power x. It is like a to the power x. E to the power x. So this 2 to the power x, same procedure. So it f of 2 plus h. So f of 2 plus h is f of 2 plus h, f of 2 plus twice etc etc up to go to n minus 1 etc. So f of 2 is 2 square, f of 2 plus h. So it is, this one is f of 2 plus h. So it is 2 square into 2 to the power h. So same procedure like the previous two, 6 and 7, and take the limit. This limit also you have got it as 1, no, not 1. This limit is what? Log of, it will come in terms of log. Then this is again polynomial. So this so these are the examples I am doing here. You work out it on your own. So I am stopping here now. Thank you.